Good morning, dear students. This morning, we shall try to finish everything about descriptive statistics so that by next week, we could begin with inferential statistics. Good morning once again. So this morning, we will try to finish everything about descriptive stats so that by next week, we could begin with inferential statistics. So first in the list, if you remember, prior to your examinations, we had a discussion about constructing a frequency distribution table, yes? So this morning, we will do it through Excel. So those who have laptops with them, get it ready. So from frequency distribution table, we shall move on to the measures of central tendency in passing because we already have touched this in our previous discussion. And then measures of variation, dispersion, and measures of positions. So this is all for this morning. So we shall take up all of the three under descriptive statistics. Okay, so first, how to construct a frequency distribution or a grouped frequency distribution using Excel. Okay, let me open the file and I'm going to open Excel. And those who are logged in, those who are able to log into Lens, I'm going to send the file now so that you can get the data from here. Okay, I'm in the process of uploading the file to Lens. So in few minutes, it will be available. Okay. Okay. So those of you who are logged in, you can check on your Lens and download the PowerPoint presentation. I've just sent the PowerPoint presentation and you can extract the data from there, particularly slide number 3. Okay, so you can find the data in slide number 3. Okay, because we shall use this data to illustrate or to show how to construct a group frequency distribution using Excel. Okay, so for instance, okay, this is the data set. The data set, this is our data set. The intelligence quotients or IQ of 100 freshman students admitted at the College of Health Sciences of Cagayan State University were taken and shown below. Construct a frequency distribution with 10 classes. Use 83 as the lowest class limit. Okay, so although we did this manually before, let's show how this can be done via Excel or using Excel. So I'm going to show you two ways. There are two ways by which we could come up with a frequency distribution table, a histogram, frequency polygon using Excel. So I'm going to copy the data set. I'm going to paste it in Excel. Okay. 1 minute. Okay, can you see this now? Okay, so this is our data. I got this from the PowerPoint presentation which I sent to you I sent to Lens. It's in slide number 3. Okay, slide number 3, you can get the PowerPoint should I say this data set of 100 IQ of 100 students, freshman students of the College of Allied Health Sciences. Okay, so what are we going to do? We are going to construct a frequency distribution table out of this data. Okay, so let's proceed to Excel. So the first, remember that when, or should I say, remember the steps, recall the steps in constructing a frequency distribution that we have discussed before. First, identifying the lowest and the highest score. So we could easily do that no longer by inspection but by using the max and min function of Excel. So using your max and min, if you are familiar with those functions, you can click on one cell, equals, and type in max. Okay, max. Okay, that gives the maximum or the highest value. Again, equal sign, max. You only have to click on this, okay, max, and then you highlight the range of scores. And enclose it in a pair of parentheses and then enter. Okay, so that's it. The maximum, let's label it. This is the maximum or the highest. Okay, maximum score is 120. Next, identifying the minimum. Again, let's make use again of the minimum function. Minimum. Identifying the minimum or the lowest value in this data set. Okay, type in equal sign and then just type min and it will display the function min. You simply have to click on it and highlight the range of scores or your data set. And again, enclose it in a pair of parentheses and then okay, that's it. Okay, the lowest value therefore is 83. Okay, now range. Okay, computing for the range. Range is equal to, okay, remember the definition of range? It's the difference between the maximum and the minimum score. So you simply click on the max minus, okay, the min, and then enter, and that gives the range. Now, going back to the problem, what did it say? Okay, the problem says, let's go back. Okay, let me highlight. Going back, the problem requires 10 classes. Okay, and it's very specific, 83 as the lowest lower class limit. Okay, so please take note that our number of classes is 10. So let's go back to our Excel. So now we are ready to compute for the class width. But let me just write K, which is number of classes is 10. Okay, the number of classes is 10. So I is equal to I, which is the class size or the class width, 10. Okay, why this is too big? I will now be equal to, okay, the range, which is equals, equal sign, and then click on the range, and then divided by, or the slash sign for divided by the number of classes, which is 10, and enter. And take note that you'll end up with 3.7, but we round that up to 4. Okay, so this is our class size or class width. Class size or class width. Now we are ready to set up the classes. Okay, so lower class limits, lower limits. Okay, so let this be the lower limits, and the next column be our upper limits. Excuse me for a while. Okay, so the lower limits, first lower limit, going back to the problem. Okay, so the lower limit of the first class is 83. Okay, so 83, 83. Now, take note that to get the succeeding lower limits, we simply add the class size to the previous. So, the succeeding lower limits will be obtained by simply adding 4 to the first or to the lower limit of the first class. So, 83 plus 4 plus 4. Okay, and then you simply have to drag this down. And How many classes are we going to set up? 10 classes. So this is the second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th class. Okay? How about the upper limits? Upper limit of the first class is obtained by adding I minus 1. I minus 1. Class size minus 1 to the lower limit. So this is simply equal to 83 plus I minus 1, 4 minus 1 is 3. Okay? And then drag this down to set up the, or to get the upper limit. So that's how to set up the class, okay, class intervals. So 83 to 86, 87 to 89, or sorry, to 90 rather, 91 to 94, 95 to 98, 99 to 102, 103 to 106, 107, 110, 111, 114, 115 to 118, and 119 to 122. Okay, next.
Excuse me.
Next, how to determine the frequencies. Okay, so to determine the frequencies, you go to data, and data analysis. I hope you have this in your installed in your Excel. If not, you check on the add-ins and click on data analysis. And then along data analysis, you choose histogram. Okay, histogram. And then click on it. Okay. Input range means all the set of scores or all the scores should be highlighted. Okay, that's the input range. Once again, okay, let me start. From here, click on any cell, and go to data. So in your data tab, you'll find data analysis. Okay, and click on data analysis and go to histogram. Okay, and this will pop up. Okay, this requires an input range. Input range, highlight all the scores. Okay, highlight all the scores. And the bin range, okay, bin range, you simply highlight the upper limits. Okay, maybe use the upper limits only. And then chart output. Okay, click on the chart output. Click on output range and then chart output. And then press OK. Wait for a while. Okay, so take note that it has already identified, or should I say, displayed the frequency and a histogram. But we only need the frequency, so let me just copy the frequencies. Okay, Control C. Then get back to sheet number 1, so I could add one more column for frequency. Frequency. Okay, and Control V. Okay, so if you get the sum, there should be, okay, if you take the sum, then you can use auto sum. Okay. SUM or type in SUM, that gives the sum of all of these entries or sum of the frequencies, or if you see the sigma sign, that gives the auto sum or the sum. So correct, 100. So there are 100 students in the study, and the frequencies are as follows: from 83 to 86 to from 87 to 8 to 95, and so on and so forth. So this is the first technique. But there is another way by which we can set up a frequency distribution. That one involves using a pivot table. Okay, so let me show you the other step or the other technique of constructing a frequency distribution by Excel. So let me copy the data set. I'll start anew using another sheet. Okay, Control C. Then add one more sheet. I'll put it in sheet 3. And let me paste the data here. Let me just label. These are IQ scores. Okay, IQ scores. Now in the first technique, the data are presented in a tabular manner, cross-tabulation table, or should I say columns and rows. However, in the second technique, it requires the scores to be listed vertically or in one column only. Okay, so I have to rearrange the scores or cut and paste such that they all appear in one column. Okay, let me just copy everything and put it in one column. Letter D, column D. Column E, Control C. Column F. Column G. Column H. Column I. And the last column, column J. So I should end up with the 101st row. Okay, correct. 101st because the first row was my column label. Okay, or the label or the name of the variable, which is IQ scores. Okay, so one important reminder, the data should be arranged in a column. Okay, so we have to highlight it. Now we have to highlight including there should be a label. So let's label or including the label, I should say. Highlight including the label until 101. And then we go table, pivot table. Okay? And click OK. Once again, highlight the data including the label or the name of the variable. Go to Insert and click on Pivot Table. And then click OK. Okay, so your pivot table field. Can you see this? Okay, on the right side of the your window. You drag on or click on the IQ scores. Click on the IQ scores. This is the variable, our variable IQ scores. We only have one variable anyway. So, drag, okay, drag the variables to the rows. I'm going to drag, okay, this is dragging the variable IQ scores to the rows. What does it do? What happens? Take note that it lists, look at this side of the window, or look at this side of your Excel sheet, the individual or the unique values of the IQ scores are listed. 83, 85, 87. So see, the minimum really is 83. So the lowest value is 83 and the highest value is 120. Now, moving on. Go back to the pivot table field. This time we are to drag IQ scores, okay? Drag the IQ scores to the summation values. Look at this box. Okay, there are 4 boxes: filters, columns, rows, and values. So the first thing that we did a while ago was to drag the IQ scores to the rows box. And what will happen? The unique values will be listed down. Individual, yan. Okay? It will list all the unique values of the IQ scores. Next thing to do, we drag the IQ scores to the summation values box. Okay, summation values. This box. I'm going to drag the IQ scores to the summation values box. And what does it do? Take note that it will display the sum. Okay? Look at this column, sum of IQ scores. What do we mean by this? 83 means there is only one who got 83. There is only one who got 85. There is only one who got 87. What about 180? What does it mean by this? There are 2 students who got 90. 182, there are 2 students who got 91. 182, I should say, means there are 2 students who got 91. Okay, but we're not interested about sum of values. Okay, what we want is the count or frequency or number of students who got 83, 85, 87, and so on. So going back to our pivot table field, okay, going back to that box on summation of values, click on this, okay, click on this small icon here, I. If you could see this, click on this, okay, and this will pop up. Okay, the pop-up will ask for the pop-up will ask for, can you see the pop-up? Wait, let me just check. Yung class with lang. Ay, yung class with. Sige, balikan natin mamaya. Balikan natin mamaya yung sa unang, i-review natin. Okay, review natin. Sige, review natin yung unang, technique mamaya. Pag matapos muna natin to. Okay? Tapusin muna natin to. So, we're not interested. How about the pop-up? Can you see it? This one? Okay, instead of sum, we want count. So instead of the sum of scores, of IQ scores, we want the count. Ay, hindi nakikita yung pop-up. Sige, saglit lang. Saglit, picturean ko na lang. So instead of sum, we will click on count. And then OK. So it will automatically change the values along the second column into the count of IQ scores or frequencies. Okay, frequencies. But take note that these are individual listings of scores. And we want a group. Okay, group frequency distribution table. So what are we going to do next? We have to choose, okay, or navigate along the row labels, along any of these values, choose one, and then you right click, and then go to group. Go to group. Okay, and take note that we are to start with 83 and we end at 120. Okay, because those are the lowest and highest score. And our by here means our class interval. And what did we set up as our class interval? By 4. You can see this. Hindi nyo nakikita. 1 minute, set up lang. Kasi itong nag-capture ng video eh. Tapusin ko na lang muna, gawan ko na lang kayo ng tutorial. Tapusin ko na lang muna. Okay? Tapusin ko na lang muna kasi hindi nakikita yung pop-up. So, by 4. Okay? Okay. So, look at the output. Okay, look at the output. These are now the frequencies. 2, 4. Okay? How did I do that? Once again, I will hover or choose any of these row labels, okay, and right click, and then this will be displayed. Choose on group, starting, which is the lowest value, 83, ending 120, and our class interval is 4, and click OK, and it will automatically display our frequencies or the frequencies. So, and the classes also. So, the classes were already set up, 83, 86, 87, 90, 91, 94, 95, 98, and so on, and the frequencies. So, let's compare. Let me copy. Okay, Control C. And then compare it to our previous answer. Our previous answer is this. Let me have it here. Let's check if they are exactly the same. Oh, okay. So this is from our first. Let me highlight. Okay, this is from the first technique. And this came from the second technique. Okay, so this is from the second technique. Now compare. The answers are the same. So we were able to come up with exactly the same tables. If you cannot follow, it's alright. I'm going to make a tutorial na lang kasi the pop-ups are not displayed. Hindi makita yung pop-up. Hindi makita yung pop-up. Sige. Don't worry. Gawan ko na lang kayo ng tutorial. Okay, so far we have shown two ways by which a frequency distribution could be constructed through Excel. Now, how about a histogram? Okay, going back. So for a histogram, okay, let me copy this first. And I'm going to use another sheet for my histogram. I'm going to label this as the IQ scores. And this is the frequencies. Okay? So we simply have to highlight, and go to insert. Okay? And go to recommended chart, recommended charts, and choose the clustered column. Okay? Clustered column. And this will be displayed in your, okay, in your worksheet. However, when we described or when we discussed about histogram, if you could remember, we said a histogram is different from the ordinary bar graph because a histogram, or in a histogram rather, there should be no spaces between, okay, between the bars. So how shall we edit this? Okay, click on the graph, and this will pop up. Format data point. Okay, your format data point will appear. And then we simply have to change the gap width to 0. Okay? Because a histogram, or in a histogram, there should be no spaces in between the bars. Okay, once again, undo, para ipakita natin kung paano nangyari. So let me again, delete muna natin. Once more, highlight the table, including the labels, go to insert, recommended chart, and yan, the column type. Okay? Vertical bar graph. And then click on this. If you click on this, once more, format data point. Format data point will appear. It's not format data area, but format data point. Okay, format data point. And see, click on the bars. Once again, once more. Click on any one of the bars and then look for this format data point. Format data point. And then you have here 3 options. Yes, the bucket and the pentagon and the bars. So you click on the bars, and for data, for gap width, change it to 0. Because originally it was 200+%, so gap width should be 0. Okay, and so that's it. Now, to distinguish one bar from the other, we can, okay, we can format from chart design, or okay, here bucket, the bucket. Click on this. Yes. Okay, so again, for format data point, you can choose the bucket, and click on border. So since our vertical bars are colored blue, choose another color for the border to make the distinction. Maybe red to make a contrast. Okay, so we can choose red. Okay, instead of blue, I'm going to choose red. Okay, there it is. So now you can distinguish one bar from the other, and this is now your histogram. Now, should you wish to add labels along your axis, just click again and go to Design. Click Chart Design. There, Chart Design. And then, once more, click on this, go to Chart Design. There, Chart Design. And click on the first, which is Add Chart Element. Wow. Which one would you like to add? Okay, a label along your horizontal axis. So, primary, horizontal. Okay, or there, axis title. What are these values along your x-axis? These are the IQ scores for the classes. IQ scores. And if you want to add, you want to add a label, or if you want to label your y-axis, just the same. Chart design. There, go to add chart element and add axis title along this time the vertical. Okay, that's it. Their vertical axis. What is the title of your vertical axis? These are frequencies. Frequencies. Okay, the frequencies. Okay, so this is our histogram. So we were able to draw our histogram. pop up. Okay, let's try whether the pop-ups will show up now. Okay, tingnan nga natin. Okay, let's go back. Go back to sheet number 3. Sige, try natin. Okay, so let me again show you how to construct the frequency distribution table using the second technique, using a pivot table. Highlight all the scores. Please mag-feedback kayo kung meron. Okay, kung nakita niyo yung pop-up o hindi. Kasi try ko ipakita yung pop-up. Okay, so insert pivot table. Insert pivot table. Okay. Can you see the pop-up now? O, yan na yung pop-up. Okay, so yan na. And then, click OK. And then, your pivot table fields will also appear. Okay, so once again, drag the variable IQ scores to the rows. Okay. Ay, naka-ano na siya. Naka-regroup na siya. Hindi, ungroup muna natin. Okay. Ulit. Naka-group na kasi siya kanina. Ulitin natin. Ulit. Highlight including the variable name. Highlight including the variable name. Okay? Go to insert, click pivot table, and then click OK. And it will open in a new sheet. Okay? And then the pivot table will appear. Now, drag the IQ scores, because you only have one variable anyway, IQ scores, to the rows backs. Okay? After dragging, okay, you will see a listing of the unique values. Okay? Labeled as, or should I say, raw labels rather, listing of the unique values of IQ scores. Next, once more, go back to the pivot table field, drag IQ scores to summation values box. Okay, there it is, summation values box. But what did I say? Since this is summation, it will just give you a sum of. Okay, sum of. So look at this. So 83, 85, 180, 182, 288. Okay, 288 means there are 3 students rather. There are 3 students who scored 96 because 96 times 3 is 288. 190 means there are 2 students who got 95. But we're not interested about sum of scores. We want frequency, okay? We want count of scores. So, go back to the summation values box. Go back to the summation values box and click on this small icon here. Okay? And instead of sum, what is highlighted is sum. Okay? But we are not, like what I said a while ago, we want the count or the frequency. Okay? We want the count or the frequency and then click OK. Oh, so automatically, it will now display count of IQ scores. Okay? The frequency of scores. Now, but this is not grouped because it only lists down individual scores. We want a grouped frequency distribution. So, along your row labels, along the row labels, you choose any value, click on any value, right click on it, and you choose group. Okay, choose group. Starting 83, ending 120, don't mind that. We will only vary by. Okay? We will only vary by. Once more, this will pop up, giving the grouping. Starting at 83, ending at 120, by, ito lang yung i-change natin. Yung by means class size. Anong class size natin kanina? 4. So, I'm going to use 4. And then, after that, you simply click OK. Okay. So, look at this now. Your row labels or your classes, 83 to 86, 87 to 90, 91 to 94, and your frequencies also have already automatically updated to 5, 8, 11, 15, 19, 22, 9, 5, and 4. Okay? Okay, so that's it. So this is the second technique in coming up with a frequency distribution table using a pivot table. Okay, next step, we are to construct a histogram. Okay, so what shall I do? Just copy, excluding, okay, excluding the labels. Okay, excluding the labels. Otherwise, the pivot table will also be copied. So, ito na lang. Exclude the labels. So, I'm just going to highlight the rows, or should I say, the classes and the frequencies. Control C and paste it anywhere or in a new sheet if you want a new sheet, or within that same sheet, no problem. And I'll just have to label this as IQ scores and frequencies. Okay? So, what are we going to do now? We will highlight. We highlight including the labels. Highlight including the label. And then, go to Insert, Recommended Chart. We want the vertical bars or vertical columns, clustered column. Click on it. Okay. And this will be displayed. Okay? However, a histogram does not have spaces in between the bars. So, we format. Format lang natin. Okay? Pwesto muna natin siya. Let's put it beside the table. Okay? So, click on your graph. Yan. Format data point. Look at this side. Okay? Right side of the screen. Format data point and select series options. Select the bars. Because the first is a bucket. There is a bucket here. We have here a bucket. We have a pentagon. And here we have the bars. So, choose this. Ito. Choose this. And you can change the gap width. Okay, let's change the gap width. So, from 219 degrees or percent rather, change it to 0. Okay, make it 0. And that's it. And then again, if you want to distinguish one bar from the other, go to the bucket, option. Okay, bucket option, ito. This is the bucket option. And then border referring to the border of each bar. Change it into a new color or a different color because the bars are already in blue. Let's choose a color that will make a contrast with blue. I'm going to choose red. Okay, a bucket siya lang. Lahat dapat. Okay, red. Okay, and that's it. So this is our histogram. Okay, the histogram. And to further format your histogram, if you wish to add a title for your axis or a label for your axis there, look on this or check on the add chart element, upper left corner, just below the file tab. Add chart element, click on that. There's a drop down arrow. There's a drop down arrow beside it. And you can choose axis titles, primary, horizontal, the horizontal axis. These are IQ scores. Okay? IQ scores. And add, again, go back to that option. Yan. Add chart element, click on the drop down arrow, axis titles, this time vertical, primary vertical. There it is. Okay, and you can simply edit this. These are the frequencies or frequency. IQ scores, and to be consistent, let's make it frequencies. Okay, IQ scores versus frequencies. So this is our histogram. Chart title, let's say, this should be IQ scores, but just to tell you that this is a histogram. Okay? Okay. So now I think we could move on to the next because it's already 10:30. So let's proceed to the next. Okay. Are there questions on setting up the frequency distribution table and the histogram? One thing more pala, yung sa frequency polygon nyo. Sa frequency polygon, the frequency polygon is a line graph of the midpoints. Midpoints versus frequencies. Okay, midpoints versus frequencies. Okay, let's insert one column here for class marks or midpoints. This is from the previous table. Okay, class marks equal to, what is class mark equal to? Class mark is simply equal to lower plus upper. Once more, lower, this is supposed to be plus. Plus upper, let's enclose it in a pair of parentheses. Lower plus upper divided by 2. Enter. Okay, so these are the class marks. Okay, so how to prepare a frequency polygon? So to prepare a frequency polygon, you simply highlight the class marks and the frequency, and then go to insert. Again, recommended chart. Choose on their frequency. Okay, the frequency. Click on it, and there it is, our frequency polygon. However, this must be dropped to 0, and this one also should be dropped to 0. That's the only difference. The only difference is we have to drop this down to 0 and drop this down to 0 along the x-axis, because a polygon is a closed figure. So that's how simple it is. Okay? Then you can do formatting. If you want to label again your axis, you can add chart elements, axis titles, okay, horizontal. These are the class marks, okay, class marks. Take note that along the x-axis are the class marks, and along your y-axis are the frequencies. Okay? Okay, so that's it. So we can move on to the next. So for your assignment, this is your assignment. Okay? This is going to be your assignment. Construct, okay, in a study of physical endurance levels of male college freshmen, the following composite endurance scores were collected. Okay? So I want you to construct a frequency distribution, relative frequency distribution, frequency polygon, histogram. By the way, what is a relative frequency distribution? I think I failed to mention about a relative frequency distribution. We just add a column for, okay, let me show you. Here, relative frequency, I think this is quite glaring. Okay, so frequency, and then we can add another column for relative frequency. Relative frequency is simply frequency of that particular class divided by the total frequencies. Okay, so relative frequency of the first is equal to 2 over slash this 100. Okay, or just type in 100 so that it will be constant. It's not going to change. And all you have to do is to drag this down. Okay, so that's it. Relative frequency, 19, 15. Let's get the sum. This is supposed to be 1. Sum of all these entries. Otherwise, something is wrong. Oh, correct. The sum is 1, meaning 100%. Okay? So this is how to construct or to add another column for relative frequency. Once again, how is relative frequency computed? Frequency of that particular class divided by the total frequencies, which is 100. In this case, 100. Okay, so all of this will now comprise your relative frequency distribution table. But just your classes and your frequency is your frequency distribution. So once again, relative frequency distribution includes or you simply have to add one column for relative frequency. And how is it computed? Frequency of that particular class divided by the total. Okay, the total frequency. So 2 over 100 and so on and so forth. So if you have entered the formula, you simply drag it because that will apply to the rest of the rows. Okay, and the sum of it should be equal to 1 to mean 100%. I think that is clear now. So now we move on to the next. Okay. Okay, so this is for your assignment. So please take note of your assignment. Okay, you can find this in your PowerPoint presentation, in the PowerPoint presentation which I have uploaded in Lens. So for measures of central tendency, as quickly as we can, your mean, median, and mode. Okay, so what are the characteristics? This is one thing I failed to discuss to you last time. It's the most reliable. This is the most reliable, most widely used, most sensitive measure of central tendency. Why most sensitive? Because it could be easily affected by high and low scores. Okay, because when we compute for mean, all scores are considered. It is the most widely used measure of central tendency. It is commonly known as the average, although the median and the mode are also known as averages. So simple mean is computed in this manner. Add up all the values or observations of a certain variable divided by the sum, okay, or by the total, divided by, or divide the sum rather by the total number of values, cases, or observations. Sum of all the values over number of values in the distribution. Okay, as fast as we could. The following data, example number one, the following data gives the aflatoxin levels of raw peanut kernels. The measurement, however, is not specified, and the values are as follows: 30, 26, 26, and so on and so forth. How many values are given? 2, 4, 6, 8, 10, 12, 14, 15. Okay, 15 values, and then we are to find the mean. So we simply add up the values, summation of all the values, divided by 15, and that's equal to 32.46. 32.46. Now you can use Excel also to find the mean. Huwag na lang, later na lang. And for weighted mean, so there are two types of mean. Simple mean, simply add up all the scores divided by number of scores given. Weighted mean, if, okay, for instance, computing for your grades or for your CGPA, that requires a weighted mean because it depends upon the units assigned to a particular subject. So CGPA is an example of weighted mean. Okay, weighted mean yun. Because we have to consider the number of units. So if all subjects have equal weightage, okay, then we simply add up all the grades. But if there are subjects that are credited 3 or 4, then that one requires weighted mean. So the formula for weighted mean is summation of x times w, where w represents the weight associated to x, divided by summation of the weights. Okay? Like this. Weighted mean, the following represents the responses of 50 randomly chosen respondents in one item of a research questionnaire. So later, when you will be administering our survey or doing your own researches and you make use of a questionnaire with the following responses: agree 5, strongly agree 4, agree 3, disagree 2, strongly disagree 1, find the weighted response of the respondents. 17 answered 5, 11 answered 4, 9 answered 3, 12 answered 2, and 1 answered strongly disagree. 17 plus 11, that's 28. Okay? 28 plus 9, okay? 37. 49 plus 1, 50. Correct. Okay? So, how shall we solve for weighted mean? Ayan, you simply have to multiply. Okay? Yan, 5 with 17. 4 with 11, by 11 rather, 3 by 9, 2 by 12, and 1 by 1, divided by, okay, 50. So, summation of xw over w. So, 5 times 17, 4 times 11, 3 times 9, and so on, divided by 50. 3.62, which is, okay, interpreted as strongly agree. Now, how do you interpret your scales? Yan, ito. Table of interpretation. Please take note of this because when you will be in your third year, I'm sure you will be making use of your Likert scale when you will administer a survey or when you will do your simple research. So, within this bracket, 4.2 to 5, very strongly agree. 3.4 to 4.19, strongly agree. So, let's go back. Answer is 3.62, which is interpreted as strongly agree. Okay, moving on to the next. What are the uses of the mean? The mean is used particularly when the data is of the interval and ratio type or levels of measurement. Okay, interval and ratio. Those that could be measured, quantified, those that could be yan, interval and ratio. Ratio with true zero, interval without real zero. When there are no extreme values in a distribution, since it is easily affected by extremely high or extremely low scores. When higher statistical computations are required or are wanted. When the greatest reliability of the measure of central tendency is wanted, since its computation include all the given values. Okay, every single score is considered when computing for mean. Okay? Unlike when we compute for median and mode. So that's why it is the measure of central tendency with the greatest reliability. However, one of its limitations or disadvantages, it could be easily affected by extremely high and extremely low scores. Okay, next, median. Positional measure that divides a set of data exactly into two parts. Oh, you know this very well. It's the central score. Okay, so centrally located between the highest and the lowest observation. And to determine the median, we simply arrange our array or data set in an ascending or descending order, and the middlemost value is the median. If there are two middlemost values, then we get the average of the two. Okay, we get the average of the two middlemost values, and that gives the median. Okay, once again, if odd, the median is the number located in the middle. Exactly. But if the number of cases is even, there will be two Okay? 2 values at the middle. For example, if you have 10 values, the middle values are 5 and 6. So, get the average of the 5th and the 6th values. And that gives the median. Okay, that's it. So, n plus 1 over 2 for odd, and you'll have exact value. The average of n over 2 and n over 2 plus 1, largest observation of n is, this is for even. So for instance, in example number 1, we dealt with 15, yes? 15 scores or measures. Using the same data in example 1, find the median. 2, 4, 6, 8, 10, 12, 13, 15. Odd numbered. So 15 plus 1, 15 plus 1, yan, 15 plus 1 is 16 divided by 2 is the 8. So therefore, we are looking for the 8 score. Okay? The 8 score in the data set. But prior to identifying the 8 score, arrange the values from lowest to highest or in an ascending manner. So arrange this into lowest to highest: 16, 22, 23, 26, 26, 27, 28, 30, 31, 35, 36, 37, 48, 50, 52. So this is also one technique. Strike out 16 and 52, strike out 50, 22, strike out 23, 48, 26 with 37, 26 with 36, 27 with 35, 28 with 31, which means this is the middlemost value, which is 30. Okay? Next, we move on to the next. How about if our number of cases or number of observations is even? So, for instance, this is the data about birth weights of live-born infants. And there are 5, 10, 15, 20. Okay, 20 measures or 20 observations or cases. How shall we determine the median? So first, arrange the sample in an ascending order. Okay, ascending order. And then since our n is even, there are two middlemost values. We have the 10th and the 11th. Yes, the 10th and the 11th. So once again, you can apply the technique which I just did a while ago by striking out. So this is now arranged from lowest to highest. Strike out this with this. 581 with this. Strike this out. Strike that out. Strike this out. And this with this value and this value. Okay. Sorry, I skipped one. May na-skip pala ako. Okay, wait. Undo na lang natin. Okay, strike this with this. Ito at saka yan. This with this. This with this. This with this. This one and this one. Okay, this with this. This one and with this. So take note that there are two values remaining. Okay, so let me highlight. There are two remaining values which are 3,245 and 3,248. In fact, this is your 10th value. This is your 10th, and this is your 11th value. So, get the 10, 3,245 plus 3,248 divided by 2, and that gives our median, which is 3,246.5 grams. Now, what are the uses of the median? So, we use the median for ordinal and ranked measurements. A while ago, mean. What did we say about mean? We use mean for interval and ratio measurements. And when there are extreme values, so distribution is skewed. Hindi siya normal. Okay, it's skewed. And for open-ended distribution, that is the lowest or the highest class interval are both defined. Okay? When one desires to know whether the cases fall within the upper halves or the lower halves of the distribution, you want to see location, upper half or lower half. Now, we move on to the next, mode. Okay? This is the most frequently occurring score. Okay? The score having the highest frequency, most frequently occurring score, but it's the least reliable measure of position. Okay? So how do we solve for the mode? By observation or by inspection. Only by inspection, no calculation. No computation is needed. So in some instances, mode might exist or, see, might exist or it might not exist or no mode. If it exists, then there can be more than one value. Now, if there is one mode, okay, if there is only one mode, we call it a unimodal or monomodal. For example, 33, okay, 33, 35, 35, 38, 40, 46, this is the mode. Mode is 35, there is only one value and it's unimodal. Example number 2, if we have 33, 35, 35, 38, 40, 40, 40, 46, yan, 35 and 40, 40. We have two modes here, 35 and 40, because both 35 and 40 appeared twice. So it's bimodal. Okay? It's bimodal. Next, multimodal, two or more modes. For example, 33, 35, and so on. There are how many modes? 35, 40, 46, and 58. So multimodal. When is it used? The mode is used for nominal and categorical data. Nominal and categorical. Kanina, median is for, go back, median is for, yan, ordinal and ranked. Ordinal and ranked measurements. For mode, for, okay, nominal and categorical data. And when a rough or just a quick estimate, because it does not require any way computation, it could be identified by simply inspecting. So when you want a rough or a quick estimate of a central value, okay, when the most popular or the most typical case or value in the distribution is wanted. Now, comparing and contrasting between mean, median, and mode. Some other properties of your mean, median, and mode. The mean always exists in any distribution. Okay, a while ago, when we discussed about mode, we said it may or may not exist in a distribution. But mean always exists in a distribution or in a data set. So this implies that for any set of data, it can always be computed. Now, the value of the mean is unique. Okay? This implies that for any distribution, there is only one possible value of the mean. Next, mode, there could be 2, there could be 3, there could be 4. Okay? In the computation for this measure, it takes into consideration all values in the distribution. Okay? All values are considered. How about median? Like the mean, median also exists in any distribution. Laging may median. Okay? The value of the median is also unique. Okay? There is no distribution with two median values. Because if there are two middle values, we get the average and that's the median. It's a positional measure. Next, mode. How about mode? It may or may not exist. It does not always exist. If the mode exists, it's not always unique. Now, in determining the value of the mode, it does not take into account all the values in the distribution. Okay, skewness. We made mention about skewed. Okay, skewed distribution a while ago. What is skewness? What do you understand by skewness? So by definition, if a graph, okay, of a distribution is, this has to do with symmetry and asymmetry of the distribution. If the graph of a distribution is asymmetric, hindi balanse, ano? The distribution is said to be skewed. Okay? If a distribution is not symmetric, okay, because its graph extends further to the right or to the left, that is, if the tail is long on the left side or the tail is long on the right side, we say it is skewed. Either skewed to the right or positively skewed, okay, or skewed to the left or negatively skewed. So if a distribution is not symmetric because its graph extends further to the left than to the right, or if it has a long tail to the left, we say that the distribution is skewed to the left or negatively skewed. So when we speak of skewness, it has to do with the symmetry or asymmetry of the graph. Okay? Let's look at this. Comparing and contrasting between positively skewed and negatively skewed and a normal distribution. Okay? When is it normal? So normal if your mean, median, and mode are all located at the center. So this one is, kaya nga naka-label no skew. No skew, normal. This is normal. Your mean, median, and mode are all located at the center. Mean, median, and mode are all at the center. Now, let's look at the second graph. Why is it right skewed? Okay, let me highlight right skew. Right skewed. Take note that if I draw a line joining the midpoints, take note that the tail extends on the right. Okay? The tail extends on the right. This is positively skewed. Let me write it here. Positively skewed. What do we mean by that? Bulk of the scores, MOS. Okay, when we say MOS, the mod yun, di ba? Bulk of the scores are found to the left of the mean. Where is the mean? The mean is here. But most of the scores, remember that the frequency, height of the bar, yung height ng bar, speaks of frequency, ilan. Okay? Most of the scores, bulk of the scores, are located to the left of the mean. Pero ang tawag dyan ay positively skewed. Okay? Positively skewed. Most of the scores are below the mean. Look at the position of the mean, median, and mode. Mean is here, and to its left are the median and the mode. This is a positively skewed distribution. What do we mean by this? For example, if a teacher administered an examination and it's quite hard, most of the students scored below the average, the distribution would look like this. Okay? The distribution would be positively skewed. There are a few students who got high, and bulk of the scores, bulk of the students, most of the students scored below the average. Okay, I hope you got that. That's positively skewed. So that results from a very hard examination or maybe an examination in which the students are not ready. Okay? That's why the scores are mostly below the average. Positively skewed yun. Baligtad, ano? Now, how about left skewed? Left skewed for, yan, left skew, look at this time, if this is the mean, okay, the mean, the median and the mode are to the right. Nasaan si median at mode? To the right of the mean. Meaning, the bulk of the scores are on the positive direction. Mas mataas kesa sa average. Most of the scores, okay, most of the scores, bulk of the scores are above the average. Bulk of the scores are above the average. Okay, for example, let me cite an example in which the result is negatively skewed. Okay, negatively skewed. Okay, the teacher administered a quiz and it was quite easy. It was quite easy that most of the students got negatively skewed. Most of the students got high marks. So most of the students are here. Ayan, mode. Okay? Yan, mode. Bulk of the scores are above the average. That is negatively skewed. So I hope you won't get confused between positively skewed and negatively skewed. Positively skewed, you have to put this in mind. There are the tail extends. The tail extends to the right side. There are a few students who got high scores. Negatively skewed this time, the tail extends on the left direction. Most of the scores are above the average. Okay, that's negatively skewed. Let's look at the next. Ayan, look at this. So this one at the middle is normal, no skew. Mean, median, mode are all at the center. Okay, negatively skewed. Negatively skewed. Most of the scores, yan. Negatively skewed, yan. Most of the scores are above the mean. Nandito sila. The bulk of the scores are above the mean negatively because the tail extends to the left. There are a few students who got low marks. For example, in a very easy quiz, the tail is our basis for saying negatively. Negatively, the tail. Ito, positively, look at the tail. Where is it extending to the left or to the right? Kaya positively skewed. Okay? Now we proceed to, it's 11:05. Pwede mag-extend kahit ano lang, 20 minutes. Or meron pa kayong klase. Meron pa kayong klase after nito? Saglit na lang to. Measures of variation. Saglit lang. Range. Okay? Now, your measures of variation or dispersion determines the degree of scattering. How far apart are the scores? Okay? Dispersion. Now, let's compare and contrast between variation and dispersion or variability, measures of variation, and measures of central tendency. So, for central tendency, central tendency describes the central point of the distribution, and variability, how the scores are scattered around the central value. Okay? How far apart are the scores from the central value? So this is central location, for example, and scores within it determine how far apart are the scores from the central value. That's a measure of variability or measures of variation or measures of dispersion. Together, the central tendency and variability are two primary values used to describe a distribution of scores. Okay, how important are the measures of central or variation rather? Now look at this particular distribution. They have the same mean. Same mean. Pareho, nandito yung mean, gitna. However, they are shaped differently. Okay, the means are the same, but their shapes are different. Obviously, one is taller than the other. So these two frequency distributions with equal means but different amount of dispersion. Okay, so in which population are the scores more varied? Okay, look at the width, width of the graph. Ito, look. This means the scores are closer to each other, okay, as compared to population A. Okay, the gap between the scores are medyo farther. Okay, so however, the means are equal. The means are equal, but the distances of the scores from the mean are different. Okay? If I would ask you which between the two between the two populations yung more likely homogeneous or the scores are closer to the mean, and look at the size of the graph. Ito, that would be population A. Population A. Population B medyo scattered. The measures of variation are the range, interquartile, mean deviation, variance, and standard deviation. But if you still have class, it's alright. You can exit now because I will just continue para ma-record pa rin. And I'm going to upload the recorded video to Lens. Okay? So it's alright. Those of you who have classes, it's okay to exit now from our online session, but I will still continue and you can still view the video, okay, later. You can view the video later because anyway, this is recorded. Okay, so the measures of variation are the range, interquartile range, quartile deviation, mean deviation, variance, and standard deviation. You know very well range. Okay, so we will only discuss variance, standard deviation, mean deviation, and interquartile deviation this morning. Now, measures of variation, how to interpret the measures of variation. The lesser the value, the more consistent, the more homogeneous, less scattered are the observations. Okay? Because by dispersion, we mean degree of scattering. So, the lesser the value, the more homogeneous or the closer are the scores to the central point. Okay? Next, range. It's the simplest to, okay, the simplest to compute because it's simply the difference between the maximum and the minimum or the highest and the lowest. Okay, so the simplest measure of variation to calculate the difference between largest and smallest, much larger range suggests greater variation or dispersion. So if the value is too big, then that means the scores really are far apart. Next, the formula is simply highest minus lowest. Okay? So for example, using the data on birth weights and example number 3, if you could remember, 20. Okay, there are 20 observations in that data set. Find the range. Okay, find the range. Example number 3. Hanapin natin. Sa example number 3, sa median natin yun ginamit. Ayun, dito. O, yan. Okay? So, sa example number 3, okay, referring to this set of data, find the lowest and find the highest. Okay? So, let's go back. If I make a, yan. Let's go back to, where are we now? Range. We're done with skewness. Yan. Okay? So the highest in the set of data is 4,146 and the lowest is 2069. And simply get the difference, it's 2077 or 2077. Now, note that the usefulness of the range is limited. So the fact that it takes account only two values, okay, makes it a poor measure of dispersion because not all values are considered. Okay, the main advantage in using the range is its simplicity in calculation. Very easy to calculate. Now, it's always affected by extreme values. Okay? And in the process of computing the range, not all values are considered, like what I mentioned a while ago. The range does not consider variation of the items relative to the central value of the distribution. Now we move on to variance. Variance is a measure of variability that uses all the data. Okay, lahat considered. And it is the average of the squared differences between the observations and the mean value. Average of the squared differences between the observation and the mean value. So this is the formula for variance. Now, this is for a sample variance. Okay, because we have population variance, the only difference is for population variance, it will be, okay, summation of x minus mu squared over n. Okay, so please take note of the difference. When it is a sample, our denominator is n minus 1. If it is a population, our denominator is n. Okay, so please take note of that. This is for sample variance. This is for sample. And the second is for population. Okay, population versus sample. Where x is the individual set or individual values in the distribution, x is the individual value, x bar or mu, okay, depending upon whether the given is population data or sample data, okay, mu or x bar, mean of the distribution. So either sample mean or, okay, sample mean or population mean, and n the sample size. Okay, let's look into the steps. So steps in computing the variance. First, you have to identify the mean and then get the deviation of each value from the mean. Deviation means difference, okay? Difference, okay? Distance of that value from the mean. Okay, next, we square the deviations or we square the differences. So that means you will end up with all positive answers. Okay, because even if you get a negative and you square that, that will yield a positive result. Then get the sum of the squared deviations and divide it by the total number of values. But this total number of values varies depending upon whether we are dealing with a sample or a population data. Okay? So let's illustrate. So now we're moving on to example number 8. Example number 8, compute for the variance of the following sample measurements. Okay, 13, 5, 7, 9, 10, 17, 15, 12. Recall that step number 1, we have to compute for the mean. Find the mean. So mean is simply, okay, summation of the scores, summation of the data or of the observations rather, sum up all the observations divided by number of observations. So sum it up, 13 plus 5 plus 7 plus 9 and so on is 88 divided by how many observations are given? 2, 4, 6 over 8, which is 11. So that's the mean. Okay? Now, to come up with an organized, or should I say to help us find the squared deviation, we prepare a table which looks like this, okay, where x is simply a listing of the individual scores or individual observations. So take note, x are these values. It's just that I arranged it in an ascending order. And then x minus x bar, which is the second column, is simply the difference. So 5, okay, minus 11, which is the mean, equals negative 6. 7 minus 11 equal to negative 4. 9 minus 11 equals negative 2. Where did I get 11? That's the mean. Ito. Okay? 10 minus 11, 1, negative. 12 minus 11, 1, correct. 13 minus 11, 2. 15 minus 11, 4. 17 minus 11 is 6. Now, after getting the deviation, this is the deviation mentioned in the steps a while ago, or distance of each value from the mean. Ito yung deviation. As we call deviation. Deviate, how far, distance. Then you square the deviation, square deviations. So you square the deviations, all answers should be positive. Okay, negative 6 squared, 36, correct? Negative 4 squared, 16, negative 2, 4, negative 1 squared, 1, 1 squared, 1, 2 squared, 4, 4 squared, 16, 6 squared, 36. Sum it up, it's 114. Now, we are ready to compute for the variance using the formula. So, s squared, that's the variance, is equal to, this refers to the total of the last column. Okay, total in the last column there. That's 114. So, 114 divided by 7. Why 7? There. N minus 1. Why? Because it's mentioned in the problem, this is a sample. Okay, so let me highlight sample siya. Kaya n minus 1 is 7. Okay? 8 minus 1, 7. So 114 divided by 7 is 16.29. Now we proceed to the next. The mean absolute deviation, how different is this from the variance? The variance, okay, we took the deviations from the mean and then we squared. Okay? We squared each deviation from the mean. However, for mean absolute deviation, it simply gets the average deviation from the arithmetic mean. Okay? But absolute, it measures the average deviation of the values from the arithmetic mean. It gives equal weight to the deviation of every value in the distribution. Okay, now, the mean absolute deviation, or MAD, mean absolute deviation, is simply summation of the, look at this, kaya absolute siya, absolute value. What is this measure, or should I say, what is this all about? Absolute value of x minus x bar, absolute value of the difference between each, okay, each score from the mean. Okay, divided by n. Yung kanina, for variance, what did we do? After getting the deviation from the mean, we squared. Okay, we squared and then divided by the n. But this time, for mean absolute deviation, you simply get the difference of each score from the mean, get the total, divided by n. But again, it has to be absolute value. So, all positive. Now, let's look at one example. Once again, the steps are, first, you have to know the mean value and then subtract, okay, the mean value from each score. Okay, take the absolute value and then apply the formula. Okay, sample. The mean deviation of the scores of 10 students in Biostat, given the scores 35, okay, 30, 26, and so on and so forth. How many scores are given? 10, 2, 4, 6, 8, 10. Step number 1, we have to find the mean. So, mean is simply sum of all the values divided by n. Sum this up, you'll end up with 212 divided by 10, which is 21.2. Bear that in mind, that our x bar is equal to 21.2. Okay, from our previous computation. So, we are now ready to get the deviations of each score from the mean. So, how was this obtained? 13.8. You simply have to subtract 21.2 from 35. 35 minus 21.2 equals this. Minus 21.2 equals this, and so on. Okay? But, what did we say a while ago? Absolute value. This is supposed to be absolute value, so get rid of the minus sign. Okay, you don't have to, yeah. Okay, so it will be this. Then, what are you going to do? You simply add up all the, okay, all the absolute value of the differences between each score and the mean. And the sum of it is 60.4. Then, 60.4 divided by n, that gives the mean absolute deviation. 60.4, once again, that's the sum of the third column. 60.4 divided by, how many scores are given? 10. So 60.4 divided by 10 is 6.04. That's the mean absolute deviation. Okay. Next, the standard deviation. The standard deviation, it's the square root of the variance. The square root of the variance. So going back to our, okay, example a while ago on variance, ito siya. If we take the square root of this, if we get the square root of this gives the sample standard deviation. If we get the square root of this, it gives the population standard deviation. Okay? So what's the relationship between variance and standard deviation? Standard deviation is the square root of the variance. So the variance is the square of the standard deviation. So this is the most commonly used measure of variation because it indicates how closely the values of a given data set are clustered around the mean. Okay? A lower value of the standard deviation means that the values of that given data set are spread over smaller range. Okay? Dito lang, very close to the central value, or very close to the mean. So if this is the mean, and then the values are just malapit lang sa mean. Whereas if its value is large, then most likely the scores are farther from the mean. So that's how we could visualize it. Okay, now let's continue. A lower, yan na siya. Okay, the standard deviation, okay, recall a while ago that s squared is equal to the summation of x minus x bar squared over n minus 1. This is the sample variance. Yes, sample variance. Okay, and therefore, this gives the sample standard deviation, SD. Sample standard deviation. So your population standard deviation, therefore, is equal to summation of x minus mu squared over n. This gives the population standard deviation. So let's look at one example of a computation for standard deviation. This came from our previous example. Yan. So what was our answer a while ago? Our s squared was 16 point something. Okay, s squared from our variance. Let's go over variance. Our answer this. Okay, our answer was 16.29. So if the problem asks for the standard deviation, then s would simply be the square root of 16.29. Sorry, 16.29, and that gives the standard deviation. Okay? So let's go back. So your standard deviation. Okay, correct. It's 4.04. Okay? Next, the interquartile range or quartile deviation. Okay, the quartile deviation indicates the distance. Okay, we need to go above and below the median to include 50% of the scores. Okay, it is based on the range of the middle 50% of the scores instead of the range of the entire set. Your interquartile deviation is given by the formula QD, IQD, interquartile deviation is Q3 minus Q1 over 2. Now, you don't know yet Q1 and Q2. Okay? These are measures of position, location. Q3 for quartile 3, that's 75th, equal to the 75th percentile. Q1 is 1/4 of the distribution or 25 percentile. Okay, QD is Q3 minus Q1 over 2. Yan, third quartile, first quartile. Now, may we skip IQD first? Let me discuss with you first quantile so that you will know how to determine here Q3 and Q1. Because interquartile deviation requires Q3, identifying first your Q3 and your Q1. So may I skip this meantime and may I move on to quantiles? Okay, quantiles. Generally, your quartiles, your deciles, your percentiles are called quantiles, your measures of position. It is treated as an extension of the concept of median. So if in the median, the value divides the given distribution into two equal parts, the distribution in quantiles is divided into, for quantile, 4 equal parts. For decile, 10 equal parts. And for percentile, 100 equal parts. Okay, let's begin with quartile. Okay, quartiles refer to the values that divide the distribution into 4 equal parts. Okay, represented by Q1, Q2, and Q3. So if this is your distribution, at the middle will be Q2, which is your median. And then we have a lower quartile and an upper quartile. Lower quartile is Q1 and upper quartile is Q3. Okay, so this is your Q3, this is your Q1. And these are the required in our formula for interquartile deviation. Q2 is in fact the median. How do we find quartile 3 and quartile 1? The first quartile and the second quartile. Quartile 1, or should I say, the formula in identifying the first, second, or the third quartile is this. Q sub k is equal to k referring to the 1, 2, or 3 over 4, n. Why 4? Because remember again, like what we said a while ago, quartile divides the distribution into 4 equal parts. 4 times n number of cases plus 1 minus k, depending upon whether you wish to identify the first, the second, or the third, 4 over 4, and that gives the nth score. Okay? So, for instance, the measurements are given as 6, 8, 10, 12, 12, 14, 15, 16, 20. Find Q1, Q2, and Q3. Okay, so there are 2, 4, 6, 8, 9. Okay? 6. Now let me use black. Sorry. 6, 8, 10, 12, 12, 14, 15, 16, and 20. Okay, so n is odd. Yes, n is odd. 9. There are 9 scores. There is, okay, so 9 scores. So to find Q1, we apply this formula. Okay, K equal to 1, Q1. So simply replace this K with 1 over 4 and number of cases or number of observations 9 plus 1 minus K 1 over 4. Okay, and simplify. This gives 9 over 4. Okay, 9 over 4 plus 3 over 4, which is 12 over 4, third score. Okay, so it's the third score. I think we could end up here. I will just continue with I will just upload rather a tutorial on this because it's already 12:34 and my class, next class will start at 12 o'clock. So I think we could end the stream here. Stand by na lang for the video to be uploaded in your Lens account. Bye everyone!